Hi everyone, today is day 1 of discussing DSA problems, and today we are discussing this problem single number. So first let's go with the problem statement. Given a non-empty array of integers nums, every element appears twice except for one. Find the single one. You must implement a solution with a linear runtime complexity and use only constant extra space. So this is the catch here. They are asking for linear runtime complexity and use only constant extra space. Example is, now this is a array where 2 is repeated twice and only 1 is repeated once. So we have to return 1. Similarly, here we have 4, 1, 2, 1, 2, 1. 2 is repeated twice, 1 is repeated twice, and only 4 is left. So output will be 4. If there is only one element, we will return that. So let's see how can we solve this problem. Before discussing the approach, these are the 5 things that I want to discuss. Time and space complexity. Coming to time and space complexity, they have given it should be linear time complexity. So time complexity should be big O of n and space complexity should be O of 1. Generally, these type of problems we solve using hash map. So all these elements will be iterated through a hash map and the frequency of this element will be stored in them. So the frequency of 2 will be 2 and 1 will be 1. And we'll return the frequency of a particular element which has frequency 1, and that will be the output. But problem with this is we need big O of n space complexity, which doesn't satisfy the condition. They wanted constant space complexity. So that is one approach. Next we can go with sorting. But the best time complexity we can get by sort is big O of n log n. We wanted n complexity, so this also we can go. How to solve this? Here comes the bit manipulation. In bit manipulation, we don't need extra space, and with time complexity of big O of n, we can solve this. So bit manipulation generally deals with bits, where if you're good at AND gate, XOR, or all the gates and things, so that will be easier. Now, so we have discussed the time complexity which we wanted to achieve, that is big O of n time complexity, and space is big O of 1. Why not other approaches is due to the condition that they gave, which is also the same thing. Now XOR. Coming to the XOR gate. So this is the XOR gate. Now if you give A and B as input, Q is as output, this will be the gate of this. So if both are 0, then it is 0. Both are 1, this is 1. If it is 0 and 1, then it is 1. 1 and 0, it is 1. So basically if we send same input, it will be 0. If it is a different input, then it is 1. Now here itself, you can observe a thing. If it is the same input, so this is the symbol for XOR. A XOR A will be 0. And A XOR 0 equal to A. Here 0 XOR A is equal to 0. A XOR 0 equal to A. And this follows the commutative property also. So commutative is A XOR B equal to B XOR U. As you can see, is 0 XOR 1 equal to 1 and 1 XOR 0 equal to 1. This is commutative property. Similarly, there is associative property. This is associative property of so A XOR B XOR C equal to A XOR B XOR C. So with these conditions, if you see here, they told it repeats twice. And the first rule of XOR is XOR with a number returns 0. So when you traverse through the entire row, entire array, if you XOR that element with that number, that returns 0. And that 0, if you do XOR with the unique number, it will return the same number, right? So that is the approach here. Now XOR rules are these, which I wanted to discuss. XOR of the particular number will be 0. 0 of an number XOR equal to that number, and commutative property and associative property. And the approach, as I told, we traverse through this. So they mentioned it appears twice, so we can cancel out that number using that number only by doing XOR of that number. I used that many times. So and the remaining number will be left out. So okay, I'll tell this with a better example. Now 4 1 2 1 2, if you take this, if you traverse like this, for example, we have set a resultant as 0 and start doing XOR of every number. First, in first iteration, so I can take I equal to 1 and I equal to 0, then 0 XOR 4 when it is here. Okay, so 0, if you write it in bits, 0 is 0, and for better 2 power 1 and 2 power 2, so this is 4, right? Then what is 0 0 0 0 0 0 and 0 1 1, so 0 XOR 4 equal to 4. Okay, or directly with the property 0 XOR of any number is that number, but this is with the gate. Next, coming to I equal to 1, so this we will store in resultant. It comes here, then we do 4 XOR 1, so 4, this is 4, and 1 is this one, so we get 1 and 0, and this is also 1, which is 2 power 2 plus 1 equal to 5, so resultant will be 5. Then we will take I equal to 2, so it will come here, then 5 XOR 2, same procedure, 2 will be here, and we get 1 1 1, 2 power 2 4 5 6 7, so this will become 7. Then comes here I equal to 3, if you do 7 XOR 1, so if you take here this 1 1 0, and this will be 0, this will be 1, this will be 1, so this becomes 2 power 2 4 plus 1 5. And finally, see, as you are seeing, when 1 repeated, this went back to 5, so this got cancelled out with the previous one. Internally that is happening, 1 is getting cancelled out with this and 2 is getting cancelled out with this. As is associative property, also we are doing XOR of a combination, A XOR B XOR C, it becomes A XOR B XOR C, so the duplicates gets cancelled out, so A XOR 0 becomes that number. So in the final iteration, I equal to 4, then 5 XOR 2 equal to, so this is 5 and this is 2, becomes 0 0 and 1, which is 4. This is the result we expected. So this one got cancelled out, this one, and this got cancelled out with this one, and 4 remained. As we saw, we just have done XOR of all the numbers and we found this. So generally for these problems we use XOR, where a number is repeated twice and there is only one unique number. So if it is 4 times also, it gets cancelled out. So if there are problems such as only find one unique number, we can use bitwise operations like this. So the code for this in C++ is, so this is the C++ code for this. First we declare the resultant, as I told, resultant equal to 0. and this is an iterator. We can just use for loop also by defining n equal to size of the array. Here I am just using auto iterator traveling through number, and this is similar to resultant equal to resultant XOR n. So n is generally iterating with every number, and we are storing the XOR in the resultant, and we are returning this. So if you run this, we pass the all test cases. And it beats 100%. So this is simple code for a bit manipulation. We solved first problem in bit manipulation. Thank you.